I'll stop sharing. So we have f of x equals the square root of 2 minus x less than or equal to 2, x minus 2 for greater than 2. So we're asked if it's continuous at 2 and if it's differentiable at 2. Perfect. Yes?
Will you be posting the answers for that, like practice test?
I don't want you to consider this a practice test. You still need to look at the homework we had and the classwork. I will see if I have the solutions. I'll post them for sure.
Okay, thank you.
I promise.
Just wanted to use them in addition to
Sure, I promise.
other stuff.
I agree. So we know that this function 2 minus x, this function requires that 2 minus x to be greater than or equal to 0. We know that, right? Because it's a square root of a positive number or 0. So when I solve this, I get negative x greater than or equal to negative 2 or x less than or equal to 2, which is correct. So this piece is continuous. So the square root of 2 minus x continuous on negative infinity to 2. Notice that I did not include 2. Now I know that x minus 2 is continuous on 2 to infinity as a polynomial function. So the only question is continuity at x equals 2. And as I mentioned, you have to show 3 pieces. You have to show that the limit as x approaches 2 from the left of the square root of 2 minus x equals, or not, limit as x approaches 2 from the right of x minus 2 equals f of 2, which is here, the top. If these 3 are not equal or don't exist, then the function is not continuous at 2. When I plug in 2 from the right, 2 from the left, I get 0. When I plug in 2 from the right, I get 0. This is this, so this is also 0. So I conclude, yes, continuous at 2, so basically it's continuous on all real numbers. Now the question is, f prime of x, I will differentiate this because it's very easy, it's 1 for x greater than 2. I will differentiate this. Remember, we have a formula for that. So the square root of a function so the square root of 2 minus x prime is 1 over 2 the square root of 2 minus x multiplied by the inner function prime. Can anyone give us the inner function prime?
-1.
Thank you very much. Who was that? Nick, thank you. So -1 over 2 the square root of 2 minus x. So this is -1 over 2 the square root of 2 minus x. For x less than 2, notice that I did not include 2. So I know the function is differentiable to the left of 2, this function, and this function to the right of 2. But I don't know if it's differentiable at 2. So this is the final step. So differentiable at x equals 2. So if I plug in 2 from the left, so I need to find the limit, this limit. Limit of -1 over 2 the square root of 2 minus x as x approaches 2 from the left. Does it equal to the limit of 1 as x approaches 2 from the right? If these two are equal, I'll say yes, the original function is differentiable at 2. So I have a problem. This is not differentiable. It's the limit does not exist. So 2 from the left will be a 1.9, but this will be 0. So we know that 1 divided by 0 has no hope. It's either infinity or negative infinity or DNE. This part is 1, and this will never be 1. It's this or this or this. In this case, this is all positive with minus in front. It will be negative infinity. So this approaches negative infinity, and this is 1. So I will say no. So f of x continuous on negative infinity to infinity, but not differentiable at x equals 2. Any questions? Okay, so let's take a look. Anything else?
Can we do number 8B, please?
Of course. So g of x equals 4x cubed minus 7x squared plus 12x minus 3 to the third. So this is like a function to the third power. G prime of x is 3. 4x cubed minus 7x squared plus 12x minus 3 to 3 minus 1, which is 2, times the inner function prime, which is 12x squared minus 14x plus 12. And that's it. You don't have to do anything else.
I didn't understand.
So the rule is f to the nth power prime is n times f to n minus 1 times f prime. N f to n minus 1 times f prime. Is this okay?
Yeah. Yes.
Next question. Anything else? Anything else? Anything else from my lab math or anything else from anything?
Professor, can we do number 62 for 1.6 on page 155?
155. Perfect. 155. 62. 155. Where are you? 155. 159. 155, number 62. Very good. Where are you? 62. Population growth. Awesome. So we have P of t. The function is 500 t divided by 2t squared plus 9. Let's see what they want. They even show us the graph. Find the growth rate. Okay, so part A, that's P prime of t. That's the growth rate. Find the population after 12 years, so which means P of 12. And then find the growth rate at that time. So part C will be P prime of 12. Very good pick, thank you. So in order to find P prime of t, I will consider the function as 500 times
You're
t.
still sharing your screen.
I am. Thank you so much. Sorry about that. Sorry. Okay, let me start from scratch. So 62 and 155, we're given this function, and we're asked to find the growth rate. I'm sorry, the growth rate, the rate of growth, p prime of t of this function, and then determine the population 12 years later. I think it's in years, isn't it? Yes, of course. And p prime of 12, which means the rate of change of this function 12 years later. So first, because I need to determine p prime of t, and I see that this is a constant times t, I want the constant outside. It can patiently wait. If I had here, don't change anything. If I had here plus 3, I could have not done this. But I don't. So it's just a constant times t, so I can leave it alone, and then 2t squared plus 9. Why do I do that? Because I want it to be as simple as possible. I don't want that 500 to be carried all over the place. It can patiently wait. Okay, so now I will differentiate for part A. So p prime of t, 500 stays outside, and I need to use the quotient rule because it's 1 over 2. Function 1 over function 2. Function 1 prime is 1. T prime is 1. So then I multiply by the denominator, minus t times the denominator prime, which is 4t, times over the denominator squared, 2t squared plus 9 squared. Do not attempt to simplify anything, please. Okay, so now I have 500. 2t squared minus 4t squared, that's negative 2t squared plus 9 over 2t squared plus 9 squared. Do not attempt to simplify anything. You could factor out negative 1 and just write negative 500 2t squared minus 9 over 2t squared plus 9 squared. So now they're asking us to evaluate the original function and the derivative at 12. So I like to do this. I'm going to share my screen and I'll show you the calculator. So please plug in the calculator both functions in y equals. Okay, where are you guys? Okay, good. So in y equals, clear if you have anything else. And I will enter first p, which is 500t, parentheses please, although it works without parentheses because of the numerator is a product. And divide, don't forget parentheses. If you forgot parentheses, you're going to get something else. 2t squared and plus 9. And I will enter the derivative as the second function, negative 500 in parentheses 2t squared minus 9, and divide by, in parentheses, 2t squared plus 9, and close the parenthesis, squared. So now when I go to second and table, let me know if you have this or you need more time. So when I go to second and table, I didn't mean that. I want second and table. Okay, I want to plug in 12. 1, 2. So the function, so part B, P of 12 is 20.202. I can go and see the whole number, highlighting it. And when I go to the other one, part C, P prime of 12 equals negative 1.581. And now we have to decide upon measurement unit. So this was population, right? Population growth. So this is people, number of people. And this is number of people per year. And this is a decrease. And it's, let's see, population is in thousands. So thousands of people, and this is number, so thousands of people per year. So this has to be multiplied. So you can write, if I want to multiply by 1,000, I have 2202 people. And if I multiply, instead of writing thousands, I have negative 1581 people per year. So the population 12 years from now is decreasing at 1,581 people per year. Very good problem, thank you.